Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. In episode 133, we explore the strategies and design principles used to ensure continuous network and system availability in the face of equipment failure. In modern environments, no single device or connection should become a point of total failure. Hardware redundancy prevents outages, supports fault tolerance, and allows systems to remain operational even when individual components fail. For Network Plus candidates, this topic is frequently tested, especially in questions involving high availability, network design, and disaster preparedness. This episode covers three core categories of redundancy: network devices like routers and switches, facility-level infrastructure like power and cooling, and the physical design considerations that tie them together. Whether you're building a data center, managing a branch network, or planning a remote failover site, redundancy ensures resilience. These principles are applicable in real-world design and align directly with the goals of business continuity. You'll see these concepts appear on the exam in both scenario-based and terminology-focused questions. Redundant routers are used in critical network paths to maintain connectivity if one router fails. In a typical setup, a backup router sits idle or in standby mode, ready to take over routing duties if the primary router becomes unavailable. This setup is common at both the edge, where networks connect to external providers, and at the core, where internal traffic is routed across major segments. Redundant routers are often paired with first-hop redundancy protocols, or FHRP, such as HSRP or VRRP, to provide automatic failover. On the exam, expect to identify router redundancy and how protocols enable seamless switching between devices. Switch redundancy involves deploying multiple switches per network layer, such as access, distribution, and core, so that no single switch failure can isolate devices or disrupt traffic. Redundant switches are cross-connected using trunk or uplink ports to maintain alternative paths between segments. This design ensures that even if one switch or cable fails, the traffic can reroute through another path. The exam may include questions about switch redundancy and how cross-connection prevents isolation. Stacking and chassis-based switches offer internal redundancy through a shared backplane in unified management. A switch stack allows multiple physical switches to function as a single logical unit, with one acting as the master and others serving as backups. If the master fails, another unit in the stack automatically takes over. Chassis switches work similarly, offering hot-swappable modules and power supplies that provide fault tolerance. These designs reduce management complexity and increase availability. On the exam, expect questions comparing stacked switches to standalone models. Redundant power supplies, or RPS, are standard features in enterprise-grade switches, routers, firewalls, and servers. These systems include either internal or external power supply units that provide power failover without rebooting the device. If one power supply fails, the other takes over seamlessly. Devices often include visual indicators or logs to show power supply status. RPS support uninterrupted operations and prevent sudden shutdowns due to localized power failures. The exam may test your understanding of dual power setups and their contribution to uptime. Uninterrupted power supplies, or UPS systems, provide short-term backup power during utility outages. These devices use batteries to keep critical systems running long enough for a graceful shutdown or transition to generator power. UPS units also condition power, protecting devices from surges, brownouts, and voltage spikes. UPS support is essential for preventing data loss and equipment damage. The exam may ask how UPS systems fit into power redundancy planning and what role they play in safeguarding network hardware. Generators serve as the next layer in power redundancy, offering long-duration support during extended outages. Generators typically power not only network equipment but also lighting, climate control, and other critical systems. They are part of facility-level design and may start automatically when utility power is lost. Fuel sources vary, but often include diesel or natural gas. Generator systems are particularly important in data centers or hospitals, where uptime is non-negotiable. On the exam, generator references may appear in questions about long-term redundancy and facility planning. Cooling redundancy ensures that devices remain within safe temperature limits even if part of the cooling system fails. This is achieved by deploying multiple HVAC units with independent circuits and air pathways. If one unit fails or is undergoing maintenance, others can continue cooling the environment. Overheating can damage or shorten the lifespan of switches, routers, and servers, so redundant cooling is essential for hardware protection. On the exam, expect to identify cooling as a critical component of physical infrastructure reliability. Cable path redundancy is often overlooked but just as critical. Running all cables through the same conduit or cable tray introduces a single point of failure. Any physical damage to that path can disrupt multiple links. Redundant cabling involves placing secondary cables in separate physical routes, ensuring that a single cut or fire doesn't isolate devices or segments. Redundant cable paths are especially important in campus or multi-building deployments. On the exam, you may encounter questions involving fiber cuts or building links that benefit from alternate routing. The ultimate goal of all these designs is to avoid single points of failure. These are components or systems whose failure would cause a complete service disruption. Redundancy planning involves identifying these points, assessing their risk, and applying design solutions such as backup hardware, dual power feeds, and alternate routing. Fault tolerance is the ability to continue operating despite failures, and redundancy is how that ability is achieved. The exam may ask you to spot single points of failure or choose the best redundancy solution for a given scenario. For more Cybers content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Dual Wide Area Network, or WAN, uplinks are a common method of providing redundancy for external internet or service provider connections. By connecting to two separate internet providers or through different circuits, organizations ensure that if one uplink fails, the other can maintain connectivity. These links may be configured for active-passive failover or load balancing across both providers. This design supports consistent access to cloud services, VPNs, and remote branches. On the exam, expect questions about WAN redundancy and how dual uplinks preserve business continuity during outages. Modular hardware designs provide built-in redundancy at the component level. Devices such as chassis-based switches, enterprise firewalls, and high-end routers often support hot-swappable fans, redundant controllers, and multiple supervisor modules. These components can be replaced or restarted without shutting down the entire system. Modular hardware also supports high availability configurations by isolating functions across multiple blades or modules. On the exam, be prepared to identify which modular features support redundancy and why they're preferred in large-scale deployments. At the rack level, redundancy planning involves distributing power and connectivity to avoid localized failures. Each rack may be equipped with dual power feeds, connected to separate circuits or UPS systems, and uplinks to multiple switches. Some designs physically separate systems within the same rack to prevent cascading failures. Rack-level planning is especially important in data centers, where a single failure can impact hundreds of systems. And the exam may test your ability to apply redundancy principles to equipment layout and cabling choices. Managing redundant systems requires ongoing attention. Both active and standby systems must be monitored to ensure their functioning as intended. Health checks, status indicators, and link monitoring tools are essential. Regular failover tests confirm that standby systems take over correctly and that performance remains acceptable during a switchover. Additionally, firmware and configuration updates must be applied consistently across all redundant devices to prevent compatibility issues. The exam may include scenarios where poor management results in failover or failure or unequal behavior across devices. Troubleshooting redundant setups involves more than confirming connectivity. You must also understand failover behavior, synchronization status between devices, and how routing or switching changes are propagated across redundant pairs. If redundant paths become asymmetric, meaning they handle traffic inconsistently, It can result in dropped sessions, duplicated packets, or inconsistent load balancing. Troubleshooting steps may include verifying peer status, reviewing logs, or checking heartbeat signals between devices. On the exam, expect questions where the symptoms of redundancy, misconfigurations point to inconsistent peer settings or untested failover paths. In virtualized networks, redundancy goes beyond physical links. Hypervisors are typically clustered together, so that if one host fails, virtual machines automatically migrate to another host. Shared storage systems with multipath support provide continuous access to data even if a path fails. Virtual NIC teaming ensures that virtual machines stay online if a network interface fails. These software-defined redundancies complement physical designs and are critical in cloud, data center, and virtual desktop environments. The exam may reference redundancy in hypervisors, storage, or virtual networks, and expect you to choose the correct supporting technology. Documenting redundancy is as important as designing it. Diagrams should clearly indicate which components are primary and which are backups. Cable routes, switch uplinks, and power connections must be labeled so that maintenance can be performed without disrupting service. Documentation should also include test schedules, failover procedures, and past test results. This information supports troubleshooting, audits, and future upgrades. On the exam, you may be asked how documentation helps identify redundancy gaps, or how to verify that failover components are in place and functioning. To summarize, redundancy means building a network that continues to operate even when individual components fail. This includes routers, switches, links, power, cooling, and even hypervisors. Redundancy supports uptime, performance, and resilience by eliminating single points of failure. These concepts appear in many exam scenarios, especially those involving system design, recovery planning, or high availability requirements. Your ability to understand and apply redundancy principles will help you maintain critical services and prepare for certification success. To conclude episode 133, remember that every hardware failure is a test of your network's redundancy. A resilient design doesn't avoid problems, it absorbs them. By duplicating key components, ensuring diverse paths, and maintaining failover readiness, you protect your systems, your users, and your organization's mission. On the exam and in real-world environments, redundancy is one of the most important tools in your IT toolkit. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.